2 covers binomial distributions. So what this is it is an experiment that has 2 outcomes, and every single outcome is an independent trial. So each trial doesn't depend on the previous one, and the probabilities are not going to change. Also, there's a set number of trials, and they tell you that, okay? So here's the formula for binomial distribution, but I'm going to write it out so it's not in just text, okay? So we're going to go NCR, okay? So the total number, choose the number that we're actually looking for that probability. And then we're going to do the probability of a success to the exponent x, the probability of a failure to the exponent n minus x. So the total number of trials minus x. And I'm sorry, this is x. Okay? So that will make more sense when we actually start to do questions, because you'll see the pattern that it holds. Okay? So just to add to that, the expectation for binomial distribution is the expected value equals NP. Okay, so example 1. 3% of batteries last for less than 10 hours. Okay, so we have 3%, 0.03. So this is less than, I should just do less than 10 hours. Okay, and that means 0.97 is greater than 10 hours, right? Okay, so what is the probability of 3 of your 5 batteries to last less than 10 hours? Okay? Okay, that means we have 5 batteries. So n equals 5. We have 5 trials, right? We're testing 5 of them. Okay, and the x that we want, so this is the one we want. So n is trials. X is like what we want to find the probability of. I'm going to put prob of. Okay. Now, a success is, so 3 is what we want. Less than 10 hours is what we want. That's the 3%. So the 3% is going to be a success. And then the failure is going to be 0.97. And the probability of a success plus the probability of failure is always going to equal like 100%. Okay, and that's why the Q is just 1 minus P. Okay, and we want to find the probability that 3 lasts less than 10 hours. Now, here we go. Probability that x equals 3. So we first start with n choose x. So we have 5 batteries and we're choosing 3 of them. And the probability of a success is 0.03, and we have 3 of those. And the probability of a failure is 0.97, and we only have 2 of those. So this is how many successes we have. This is how many failures we have. And these 2 are going to add up to that 5. Okay? For me, you leave this. This is what I'm testing. But if you wanted to actually get a number, let's calculate this, and I get, okay, so 5 choose 3 times 0.03 to the 3 times 0.97 to the 2, I get 0.123. Okay, so I get, this would be the cutoff for decimals, 0.0254% probability that 3 of the batteries last for less than 10 hours. And if you think about that, 3%, so that's usually 3 out of 100, but we're actually doing 3 out of 5. So yeah, a very small percentage of those are likely to like be those duds. Okay. If we wanted to do expected value, we're not expected to in this question. Let's just do NP. So we have 5 which is the trial, and 0.03. So basically, what's 3% of 5? 0.15. So 0.15 batteries will last less than 10 hours out of 5.